I'm Anil Kumar sharing with you a question on relative velocity from my student. I hope its solution will help many others. The question here is, a boat is capable of 20 kilometers per hour in still water. You wish to cross the river to a point zero point 0.6 kilometers upstream from your present position. If the current is 8 kilometers per hour and the river is 1.5 kilometer wide, at what angle to the bank you steer the boat? How long will it take you to cross? You can always pause the video, answer, and then look into my suggestions. So let's first make this sketch. Let's say this is the river. The two banks are always assumed to be parallel in such situations. And what is given to us is that the boat in still water is 20 kilometers per hour and you wish to cross the river to a point which is zero point 0.6 kilometers upstream. So you want to go from here somewhere like this, right? So if I choose this to be my opposite side, then this distance is 0 0.6 kilometers, right? So that is what is given to us. Let's say this point is A and you want to reach at B. If the current is 8 kilometers per hour and the river is 1.5 kilometer wide, at what angle to the bank you steer? So now the current is 8 kilometers per hour. So we'll assume the current to be in this direction because we are going upstream. Now that current is going to push the boat downwards. So that means we should be heading much steeper, right? So we should be heading in this direction so that the current will push it down, right? So to wherever we want to go, right? So that is what is the situation, right? Now this velocity is 20 kilometers per hour. And this for the water is given to us as 8 kilometers per hour. Does it make sense? Correct? So that is what it is. And whenever we say at what angle to the bank you steer, now in this particular case, we are interested in finding this particular angle, correct? That is the angle we need to answer. We'll call this angle as theta. This is what we need to find out. So if you look into this diagram, then this becomes that angle theta, right? So we'll try to find what this angle theta is. Okay, so that's the question. We are also given that the river is 1.5 kilometer wide. So we'll just write 1.5 kilometers here as the width of this river. Now, we know that the width is 1.5 and this is 0.6, so we can find that angle. That is good. Let's label it AB. Let's call this point as C and let's call this point as O. So in that case, the angle, this particular angle, let's call this angle as let's say alpha. So in that case, we know these two sides, so we know tan of alpha is equal to 0.6 over 1.5. So alpha is equals to tan inverse of 0.6 over 1.5. So let's find this angle first. So we have shift tan inverse of 0.6 divided by 1.5, that is 21.8 degrees. So we get this angle as 21.8 degrees. Now if you look into this side, these two are parallel. So this angle of 21.8 will be, let's actually kind of draw like this, a line parallel to this, right? So this angle will be alpha, right? Plus 90 degrees. Do you see that part? Correct? So if you see it, so the angle at B will be what? So now from here we get angle ABC. AB and C is basically equal to 90 degrees plus 21.8 degrees. Correct? So we'll add 90 degrees to this and find our angle, which is 111.8 degrees. So the angle ABC is equal to 111.8 degrees. So we get this big angle, right? Now we know the combination of angle and the side opposite. So we can use sine law. Perfect. So now we can use sine law. to solve our triangle. Perfect. So that is what we are going to do now. So we know this combination. We can find the angle theta, but before that we'll have to find this angle. Let's call this angle beta. Okay, so too many alpha betas. Okay, that's fine. So we know sine of beta over the side opposite is 8 should be equal to sine of the angle 111.8 degrees over 20 kilometers. Is that clear? So sine of beta will be equals to 8 over 20 times sine of 111.8 degrees. So the angle beta will be equals to sine inverse of 8 over 20 times sine of 111.8 degrees. Perfect. So let's figure this out. So we have 8 divided by 20 times sine of 111.8, right? And we'll find sine inverse of this number. Shift sine inverse of our answer is equal to, and we get here angle beta equals to 21.8. So that is also 21.8. Okay. Now, since we know these two are 21.8, we can find what theta is, right? So this is also 21.8. So now we know that theta should be equal to, now since this is 90 degrees minus 21.8 degrees, which is alpha, minus 21.8 degrees, which is beta, right? So that gives you the angle theta as equal to 90 minus 21.8 minus 21.8. So that gives you 46.4 degrees. So we have found the angle, which is this angle. We also find all other angles in this particular diagram. Now this angle 46.4 is also the angle here, right? So we know our triangle and its angles. Now let us so we have one of the answers, which is that the theta angle is 46.4. So this is 46.4 degrees with the bank. How long will it take to cross? So basically now we need to find the resultant velocity and this distance also. So let's find that out. Okay, so let's find resultant velocity first, which is, again, we have to apply the sine law to find this particular resultant velocity, right? So what we get here is, let's write down. So we are the resultant velocity over the angle opposite, which is sine of 46.4 degrees, should be equal to 20 over sine of 111.8. You can actually find this as a ratio. It is simpler to work with ratios, right? So from here, we know VR will be equal to product of 20 times sine of 46.4 divided by sine of 111.8. So we'll do 20 times sine of 46.4 divided by sine of 111.8, which is, okay, so let's do it again. So which is 20 times sine of 46.4 divided by sine of 111.8, right? So it is equal to, okay, so this is equal to 15.598, let's say 6. Okay, let's call it 60. So that is the resultant velocity, 15.60. Now let's find the distance A to B. So I'll find the distance A to B here using Pythagorean theorem, right? So AB will be equal to square root of 1.5 square plus 0.6 square, right? So let's find the distance A to B. So it is square root of 1.5 square plus 0.6 square. That is equal to, in decimals, 1.615. Okay, so that is the distance. So what is the time? So we know time t will be equal to 1.615 divided by 15.60. Since time is equals to distance over velocity, right? So we are writing this. Okay, let me push the page a bit. So that is the distance with us. We'll divide this by 15.6. We get this time in hours and we'll multiply this by 60 to get it in minutes. And in minutes, it is 6.2 minutes. So we'll multiply all this by 60 to get time as 6.2 minutes. Is it clear to you, right? So this time will be in hours, and what we did was that since we know there are 60 minutes in an hour, right? 60 minutes in an hour, we multiplied by 60 to get our answer. So our answer is 6.2 minutes, right? So we get our answer that will take 6.2 minutes. Now you could also write this as in minutes and seconds if you wish to, right? So we get 6.2 minutes to cross. Okay, so this kind of approximate because we did some approximation, but I hope you understand all the steps involved. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.